Does 2 plus 2 actually equal 4? Because if I have 2 fingers, then 2 fingers, now I have 4 fingers. And that's how math was understood for a pretty long time. Till Giuseppe Peano. It wasn't until 1889 till he published his axiom that allowed mathematicians to then go improve things like 2 plus 2 equals 4. So why does it? The proof isn't too complicated, but it definitely doesn't involve counting fingers. Because when it comes to mathematical proofs, we have to be very specific. So there's a couple assumptions that we have to make before we begin. First of all, what does it even mean for something to equal something? It has to be reflexive. So itself is itself. X equals X. It has to be symmetric. So if X equals Y, then the reverse is the same. Y equals X. It also has to be transitive. So if X equals Y and Y equals Z, then X equals Z. And this is important because especially the Peano axioms are specifically talking about the natural numbers, which is starting with 0 and 1, 2, 3, 4, 5, nothing in between and nothing before. So what are these 5 axioms? The first one, 0 is a number, which you think would be assumed, but is actually extremely controversial and needs to be said. Number 2, if a number, let's call it A, is a number, then its successor, whatever comes after it, is also a number. So if 1 is a number, 2 is a number. 3 is a number, 4 is a number. Number 3, 0 is not a successor. And this is what separates the natural numbers from the integers. 0 not being a successor means it cannot follow any number, or there's no numbers before it. It is the first one in the list. And number 4, if the successor of A equals the successor of B, then A equals B. Now the 5th axiom is our induction step, because the first 4 can be satisfied by a simple set, but we want it to cover every number in the natural numbers. So 0, 1, 2, 3, 4, keep it going. And this recursive idea that it applies to every number that comes after is exactly what we're going to use to prove how 2 plus 2 equals 4. So we have 3 important ideas that are being utilized in this proof. The successor function, meaning that S of n is whatever number comes after n. Second, that is our base case. A plus 0 is A, so 0 adds no value. And third, our recursive step. A plus the successor of B is equal to the successor of A plus B. So for example, if A is 4 and B is 5, the successor of B would be 6. 4 plus 6 is 10, and on the right hand side you have 4 plus 5, which is 9, and the successor of 9 is 10. So as you can see, this holds too. But let's apply it to our example of 2 plus 2. If I have 2 plus 2, I can utilize my successor function to say that is equivalent to 2 plus the successor of 1. Utilizing our third equation, 2 plus the successor of 1 is the successor of 2 plus 1. Utilizing the successor function again, can write 1 as the successor of 0. According to our third equation, can be written as the successor of 2 plus 0. Anything plus 0 is itself, so now we have this nested function that says the successor of 2. The successor of 2 is 3, and the successor of 3 is 4. Therefore, 2 plus 2 equals 4. So yes, 2 plus 2 does equal 4, and that's how you prove it. But this, just like most mathematical proofs, takes our axiom, assumes that it's true, and bases all assumptions off of it. So what happens if we assume that it's not true? Or what happens if we're working in a system that these laws don't even apply to? Take a clock, for example. If it's already 9 o'clock, and I add 9 hours, it's now 6 o'clock. So 9 plus 9 is 6. And that's because 9 plus 9 isn't 6. This is where language is very important. We say 9 o'clock plus 6 hours is 6 o'clock. So that way we know we're working in a realm of modular addition. It resets every time it hits 12. This is a topic explored in abstract algebra. In physics, since vectors have both direction and magnitude, you can have 2 vectors of magnitude 5, add them together at a different angle, and their displacement might not be 10. It could even be 0 if they're in exact opposite directions. I posted about this on TikTok, and a lot of people just said, well, isn't that just 5 minus 5? And while, yes, the math you're doing is 5 minus 5, that's why your displacement is 0. But the vector itself is 5 units long. It's not describing negative space. The negative symbol is just the direction. So technically you have 2 distances worth of positive 5 added together in a way that does not equal 10. This is why establishing a frame of reference or referring to an axiom in a proof is so crucial. You need to let people know what realm you're working in before you start working in it. Cheng, is a genius at explaining this. He gives plenty of examples of when the math just isn't mathing. One of my favorite ones says, if you have one lasagna and stack them on top of each other, you still have one lasagna. If you have a pair of tennis players and another pair of tennis players, if you mix around the partnerships enough, you can get 6 different combinations of new different pairs. So in that case, that's an example of 1 + 1 equaling 6. And then she goes on to say, now you might think that the situations above aren't really situations in which 1 + 1 equals something else because they aren't really addition, or those aren't really numbers. You're welcome to think that, but that's not what math does. Math instead says, let's work out what those contexts are and what they mean. Let's work out what the consequences are of things being like that and see what other contexts we can find in which things work in similar ways. And then she goes on to give examples in math of when things just don't work the way we think they should. For example, the cyclic group of order 2. These are examples where 1 + 1 would equal 0. An example of this in plain English would be a double negative. I'm not sad would actually mean I am sad. So those two things, when combined, cancel each other out. This applies to things like multiplying negatives, the patterns of even and odd numbers, and these kind of look like Punnett squares, but Punnett squares would be if 1 + 1 equals 1. If 1 is the dominant gene and 0 is recessive, 0 and 0 make 0, 0 and 1 make 1, but 1 and 1 also make 1. So 1 + 1 equals 1. So as you can see, it's not that 2 + 2 doesn't equal 4, it's that 2 + 2 doesn't always equal 4. And the statement, 2 things + 2 things equal 4 things, is a very vague statement based off a very specific circumstance in which those numbers are controlled under. This is why physicists utilize vectors. We don't just say, I'm going 20 miles an hour. We say, I'm going 20 miles an hour west. That's the difference between speed and velocity. Speed is how fast you're going, velocity is how fast you're going and in what direction. The resulting displacement and the resulting mathematics depends heavily on what direction and what frame of reference you're working in. And frames of reference matter in all sorts of places, not just addition. Take potential energy, for example. The equation for potential energy is mass times gravity times height. So if I'm 5 feet from the floor, the h in that equation is going to be 5. But what if that floor is 20 feet off of the ground? And what if that ground is 1,000 feet above sea level? Which height do we use to describe the potential energy? And these are the type of questions that Einstein posed that led him to understand relativity, that everything has its own frame of reference when it comes to time and space. That's what you see in the movie Interstellar. He goes to another planet, the gravity's all crazy, and 3 hours there is 23 years home, and he comes back younger than his daughter. That's highly accurate physics based on the idea that everybody's entitled to their own perspective, and that perspective can literally change based off of the gravity of what you're standing on, how fast you're going, a number of different factors. And the best part about it all is that there's no preferred frame. So in the same amount of durational experience, one person experienced 3 hours, the other person experienced 23 years, and somehow they're both correct. This is the significance of defining a frame of reference, of saying 3 hours passed by on this planet, 23 years pass by on this planet. 2 + 2 equals 4 because they're natural numbers and the successor function exists. 1 lasagna + 1 lasagna is still 1 lasagna because the lasagna is layered. So once you define the realm of what you're working in, then you can start working in it. And this is why there's no stupid questions in math, because it's those fundamental questions that we ignore every single day that get us down to the nitty-gritty of what's actually going on in this universe. You think Peano didn't feel stupid asking, why does 1 + 1 equal 2? And realizing that he had to be the one to come up with the answer? So keep asking questions, no matter how dumb you think they are, because the people who came up with this stuff were asking these same questions. Because when it comes to math and science, we never truly get the answers we're looking for. We just get more questions. But at least now we know which questions to ask, which is exactly what I'll be doing on this page from now on. Because as much as I love my little 2-minute videos on TikTok, I think some of these discussions deserve a little bit more screen time. So that's exactly what we're gonna do. Welcome to my channel. Thank you for watching, and I hope to see you next time.